going to run through a few of these questions with you, then there'll be a couple more videos after this to finish the rest of them. So 1, 2, and 3 are dealing with density. In order for us to calculate density, we need to know the formula for density. If you forget, there's a couple ways to maybe figure it out, to think about it. Number one way to figure it out is maybe use some context clues that are given to you. In the question number 2, for example, it tells you that the density of aluminum is 1.5 grams per milliliter. If you kind of put this together, that means that density equals grams over milliliters. Hopefully you remember that grams is a measure of mass and that milliliters is a measure of volume. If you remember those two things, and you can just replace that, and that's going to be mass and that's going to be volume. Another way to think about it is density is how closely packed together things are. So if something has a high density, that means it's going to be kind of heavy for its size. In other words, it's going to have a large mass and it's going to have a small volume. And again, if you think about how a fraction works, we would have, we'd have the mass on the top and we'd have the volume on the bottom. The easiest thing is just to memorize the formula, which is density equals mass divided by volume. And if we do that, then things get to be pretty easy. So number one, density, mass over volume. Mass, the grams is our indication. It also does say mass, but if it didn't say mass, grams is always the unit. We measure things in a unit. 200 grams, and we put that over 175 milliliters. Do the math on that, we get about 1.14. And again, if we did things perfect, we would put the units in here, which is going to be grams over milliliters. Number 2 is similar, but one little tricky thing here is that it gives us the density. It asks us about the mass, but it doesn't technically give us the volume. A lot of people that have worked this out have put that number 2 in for volume, but that is not volume, that is length. So if the unit is centimeter, that's a length. If the unit would be centimeter squared, like you have in geometry, that's an area. If you have centimeter cubed, which is a 3-dimensional space, that's a volume. So in order to turn this into a volume, we need to multiply it times itself to make it into a cube, which would be 2 times 2 times 2. So the volume is actually 8 cubic centimeters because our cube is 2 centimeters on each side. If we take our little triangle, a way to rearrange the formula, density is mass over volume. Therefore, mass is density times volume. So if I take this 1.5, which is density, multiply it times 8, which is our volume, we should get that the mass is 12. Put a G in there for grams, and that gets us our answer for that one. Number 3, it also does not tell us our volume. We have to figure the volume out. We've got a beaker that's got some water in it. We stick some foil in that water and the water level goes up to 56. So think about what just happened. The aluminum caused it to go from 50 to 56. That's an increase of 6 milliliters. Technically, we need to, if you did this mathematically, we would just subtract. We would say 56 minus 50. This is called water displacement. That's going to end up equaling 6, right? So that's going to be our volume. All right, so if our volume is 6, and then we've got a mass of 10, and again, density is mass over volume, 10 divided by 6, put that into the calculator, and since we've not told you how many units to round it to, 2 is probably good, and then more specifically, it would be grams over milliliters. One last thing is remember that a milliliter and a cubic centimeter are basically the same measurement. They're both a volume measurement. Let's scroll down in this little video and just do this next little section, 4 through 7, and then wrap it up. Changing gears completely, again, going back to our periodic table. The periodic table is an arrangement of all of our elements based upon a number of patterns. They go from 1 to 118 in terms of increasing atomic number, but the way that they're arranged largely has to do with their electrons. So again, we can look at the columns on the periodic table and usually get an idea of how many electrons elements have, and particularly how many elements are in their outside shell, which is their valence electrons. Now again, we can't predict this for the transition metals across the middle, but for the tall columns we can. So fluorine is in group 17. All of those elements have 7 valence electrons. Aluminum is in group 13. It is the third tall column. If you erased out the transition elements and just folded your periodic table over, this will become the third column, so there's 3 valence electrons. Phosphorus is in the 5th column, so it's got 5. Oxygen's in the 6th column, so it's got 6. Things tend to gain electrons if they're almost full. Things tend to lose electrons if they're almost empty. This tends to mean nonmetals do this because they're on the right-hand side. Metals tend to do this because they're on the left-hand side. So fluorine wants to gain electrons. It wants to gain 1, which means its oxidation number, which means its charge, is going to be -1. Aluminum wants to lose its 3 electrons. It's a metal. When it does that, its charge is going to be +3. Phosphorus wants to gain 3. Its charge would be -3. Oxygen wants to gain 2. Its charge will be -2. Remember that electrons are negative, which means if you're gaining electrons, you're gaining negative. So that's why this is not math. This is not a math thing. Okay, that doesn't mean subtract 2. That doesn't mean add 3. This has to do with its charge, which means it now has 3 more positive charges than it has negative charges. Switching gears, how many neutrons will something have? All right, so think about our format here. If you needed to double check, look at the periodic table. If you look at the periodic table, you would see that 29 is the atomic number. The atomic number is the number of protons. So the number of protons is 29. This top number is the mass. Mass is the protons and the neutrons added together. So if I've got 63 protons and neutrons and I want to get rid of the protons, I need to subtract the protons. I already know that there's 29 protons, so let's subtract those out. So the number of neutrons would be 63 minus 29. That would give us 34. Remember that elements can have different numbers of neutrons. It just makes them heavier or lighter. It changes their stability a little bit, but that's about it. They can't change the number of protons. Copper is always going to have 29 protons. Same notation on number 6. It's asking about electrons. If we look at this notation, that 6 is the atomic number, which is the protons. Remember that protons are positive, which means they typically are going to be the same as the number of electrons. So if we know where something is on the periodic table, we should still be able to predict the number of electrons it has if it's neutral. So in this case, it would still have 6 electrons because it's got 6 protons to it. Okay, and then finally, question number 7. This is one of our average atomic mass questions. Average atomic mass. I had a question like this just about on every single test we've had this year. In order to get the average atomic mass, we need to figure out the method for calculating what's called a weighted average. Normally, when we do an average, we add everything up and just divide by how many we've got. But in this case, it's telling me that 60% of all the atoms weigh 13.2. All right, so 60% weigh 13.2. And then it says the rest weigh 14.1. All right, let's put all our data together. That's kind of like if we had a pie chart. Here's 60%. So 60% of them weigh 13.2. The rest, notice it doesn't give us the rest percentage, but the whole percent's 100. So if 60% is given to us, then the rest ends up being 40%. So the rest weigh 14.1. Our method for this is we need to multiply these together and get an answer. We multiply these together and get an answer, and then we combine those answers to get everything we need. So I would take 13.2 and multiply it times 60%. Remember, percent means out of 100. So to change 60% in my calculator, that ends up becoming 0.6. Okay, so I don't want to multiply times 60. I need to multiply times 0.6. And I'm going to get an answer over here. I didn't do this ahead of time, should have. So 13.2 times 0.6 gives me 7.92. And then I multiply the other two numbers, 14.1. That's my weight. How much of it do I have? 0.4. Multiply those two numbers together. I get 5.64. And then the very last thing is I need to add these two numbers together. I get 13.56. When you get to this point, you need to be able to double check your work, because like any average, your answer should be in between the two extremes. This is your smallest number. This is your largest number. So the average should be in between those two. This one is. If you got a number like 15, 16, 17, or 2, or 100, or something like that, that doesn't make any sense. The average has to be in between these two numbers. So double check your work. You get an answer for this. If it asks you to round to the nearest 0.1, then we would need to round this up. So 13.56 would then turn into 13.6, because this digit tells me to increase that one up because it's closer to 60 than it is to 50. 56 is closer to 60 than it is 50. So we round that up to a 6. And then so 13.6 would be our answer for that. If it asks you for the units, remember a unit is anything it's what we measure stuff in. It's the thing that always comes after the thing that we're measuring. So in this case, it's AMU, atomic mass units. This is only a unit for measuring atoms. If we were measuring mass, the unit would be grams and so forth.